Review time. Let's just do a couple of questions here that kind of hit the highlights of some of the things that we've been discussing and hopefully clear up any points that are still unclear. So the first question, what is the difference between the beta and the B weight? And the answer is that the beta weight is the standardized slope, and we can compare beta weights across studies, and the B weight is the unstandardized slope. So it is tied to the units of measurement. With a GRE example, it's literally answers the question as GRE increases by 1 unit, 1 point, what happens to the person's GPA? And so that's in the units of the study. But with the beta weight, we would ask the question, as GPA increases by 1 standard deviation, what happens to the DV? So, and as you can imagine, the standard deviation is way bigger, so the beta weight's going to be larger than the B weight in this case, in this study. So, that's what the difference is between those two. And so the B weights themselves can't be compared across studies, but they're very helpful for interpretation. So there is a growing, I think, kind of movement out there that says that B weights are the thing that matter more than beta. It used to be betas were really the only thing reported, but now I think people are reporting both, or they're just reporting the B weight actually, because it's just easier for people to think about in that particular study what's going on with the B weight. So, like, how much can we decrease someone's depression, for example, by how many points? It just makes more sense to think about it in the unstandardized raw units. The second question, the Y-intercept, indicates the value of the expected value of the DV when the predictor is at 0. And if we center it, or if we standardize the predictor, then that makes the mean 0. So it means that it's the expected value of the DV when the predictor is at its mean, and oddly enough, it will always be the mean of the DV as well. So that's kind of cool. Centering is very helpful. What score on Y will the mean of X predict? Okay, so I just answered it in the last question, but remember with the scatter plot, if you go across the x-axis to the mean of the predictor variable, and then you go up to the best fitting line, and then you go across to the y-axis, you'll always be at the mean of y. If the correlation between two variables is approximately 0, what value of y is most likely to be predicted regardless of any value of x? So the answer is the mean of y. So when we have no information on that relationship, or if that relationship is non-existent between two variables, then our best guess for a predicted value of the DV at any value of our predictor will always be the mean. That's not ideal, of course. We don't want to have that haphazard a way of prediction, so that's why we try to do prediction as much as we can and run that correlation to see. That way we have a B weight to plug in, and we can make a better prediction than just the mean of the DV. And finally, what does the statistical significance of the B weight indicate? That just means that the slope of the line is more than 0. So we can have a certain amount of confidence that that slope is not 0. So if we have, if we go 1 unit over on our IV, we can be reasonably certain with a statistically significant B weight that that DV is going to move one way or the other. So we're going to move the dial on the DV as we increase 1 unit on the IV, then what's the DV going to do? It's either going to increase or decrease by some significant amount. And so that's what a significant slope indicates.